Assalamu alaikum student. In the part 1 we have discussed about the dipole moment. What is a dipole moment? And as you know now that the dipole moment is the measure of polarity of molecule. In those molecules in which a covalent bond is formed between two dissimilar atoms, they have a difference in their electronegativity. The one atom which is more powerful in the electronegativity has a high value of electronegativity, it will become partial negatively charged, and the other atom become partial positively charged. Now we have to discuss that how can we calculate the value of dipole moment. The value of dipole moment tell us either the molecule is polar or non-polar, or how much the molecule is polar. It is more polar or less polar. So we can calculate the dipole moment by using the formula. There is a we must know the two value. The one you can see there is a different the bond length, which is from the center of one atom to the center of second atom. This is the distance between the nuclei of the two atoms which are covalently bonded, and it is represented by R, and it is known as bond length. One is the bond length, which we must know. For suppose we the bond length is equal to 1 angstrom. 1 angstrom is equal to 10 raised to power minus 10 meter, and at the same time we can calculate the bond length, which is equal to 1 angstrom is equal to 10 raised to power minus 8 centimeter, right? So at the same time we must know the value of charge. Charge is represented by Q. Both the charges have equal quantity. Both the charges means partial negative and partial positive. The quantity of both the charge must be equal, and we can represent the charge by Q, and now there is a formula. You can see nu, it represents the dipole moment, and there is a bar over the nu which represent it's a vector quantity. Vector quantity means the quantity which has a particular direction, right? It has a particular direction. Nu is equal to Q multiplied by R. What is Q? It's a charge which is distorted. And what is R? R is the value of bond length between two atoms which are covalently bonded, right? Now what we have to do? We have to put the values of Q as well as R. We are having the value of R. Now what is the value of Q? Q is the charge. And what will be the unit of charge? Now you can see what will be the unit of charge. Unit of charge, it could be, there are two unit of charges. It could be electrostatic unit. You can write it like this. Electrostatic unit, you can write it like this. It could be E dot S dot U. You can write it ESU, or the other unit you are very much familiar with this term, coulombs. As we know that charge on the electron is 1.6 into 10 raised to power minus 19 coulombs, and it is equal to, we have to compare these two units because we are going to calculate the dipole moment with the coulombs, as well as we will calculate the dipole moment by using the ESU. What is ESU? E stands for electro, and S for static, and U for unit, electrostatic unit, which is equal to 4.8 into 10 raised to power minus 10. Now we have to put the value of charge as well as the value of bond energy. Now you can see 4.8 into 10 raised to power minus 10 ESU. It's a value of charge multiplied by 10 into 10 raised to power minus 8. Here I am taking the bond length in centimeter, right? I am not taking the bond length in meter here. I am taking it in the centimeter unit, and it is equal to 10 raised to power 8 centimeter. Now the answer is 4.8 into 10 raised to power minus 18. as you can see that both the bases are similar. अगर bases same हो 10 raised to power minus 10, 10 raised to power minus 8, if the bases are similar the values will be add up. Minus 10 minus 8, it will be equal to minus 18 ESU centimeter, and it will be equal to 1 dBi. What is a dBi? dBi is the unit of dipole movement, which is also a vector quantity. The dipole movement can be measured by using the unit dBi, and the unit of dipole moment in System International. System International, as you know that the System International you can write in this way SI. SI. What is SI unit of dipole moment? Here you can see the dipole moment. Again we are using the same formula. The nu bar means it is a vector quantity. It also depends upon the direction, and it has a particular direction, right? And we can show the direction by the arrow की मदद से हम इसको show कर सकते हैं. Arrow head toward the partial negative pole, and this one tail is toward the partial positive pole. So here we were discussing about the System International unit of dipole moment. The one we have discussed is 1 dBi, and now we have to discuss Q multiplied by R. Again the charge multiplied by the distance between the two nuclei of atom which are bonded covalently, or 1.60 into 10 raised to power minus 19 coulombs. This is the charge of electron, and multiplied by 10 raised to power minus 10 meter. Here I am taking the bond length in meter. Now as I told you that we can take the bond length in meter as well as we can take the bond length in centimeter. In the last value I have used the centimeter. Now I am using the meter here. Now you can see here 1.60 multiplied by 10 raised to power minus 19. Again the same rule for mathematics, that the bases are similar, so the exponent will be add up, and the answer will be 1.60 into 10 raised to power minus 29 coulombs meter. Now you can see here this C is not for centimeter, it is for coulombs, and the M small represent the meter, coulombs meter. Or you can compare it by the dBi. dBi is also a unit of dipole moment, although it is not a SI unit, but it is most commonly used unit. 1 dBi is equal to 3.33 into 10 raised to power minus 30 coulombs meter. So this is all about the description of the how can we calculate the dipole moment. And now I also like to show you some molecules, because the dipole moment does not only depend upon the charge, distortion and the bond length, it also depends upon the direction, because it's a vector quantity. As I told you that the dipole moment is represented by the arrowhead toward the partial negative pole and the tail toward the partial positive pole. So now here you can see I am having the molecule of water. This is the angular geometry of water molecule. You can see oxygen is a highly electronegative as compared to hydrogen, so it is partial negatively charged, and the hydrogen atom is partial positively charged. Now this arrow represents the dipole movement, right, toward the oxygen atom. Now here again I just want to show you another molecule. This is the molecule of nitrogen and hydrogen, and this is the molecule of ammonia, right? Ammonia contains 3 atoms of hydrogen covalently bonded with the nitrogen. As you know that the nitrogen atom contains a lone pair of electron in its valence shell. So that's why any atom which contains more electron in the valence shell will have the more electronegativity. So the nitrogen will be the partial. There will be a distortion occur, and the electron cloud distorted toward the nitrogen because it has a high value of electronegativity, and again the hydrogen become partial positively charged. So we have calculated the dipole moment by using the debye unit, as well as we have calculated the dipole moment by using the unit of coulombs meters. And now in the next part of the lecture we will discuss about the we have to discuss about the applications of dipole moment.